appreciate that. And now I'm going to share screen with you.
Which button is changing name button?
I don't know. I don't know. It's a really good question, but I bet you could figure it out. And if you can't, Larry, guess what? I will do it for you. In fact, I'm going to go to the rename button that I have, and I'm just going to go Larry. And next time you'll ask your mom and dad to do that, because that way, when I see you, I know exactly who you are. Now, I want to ask you guys a question. I want you to look at this this picture of 20 different polygons. It is on your page 1. And I want to know, can anybody find the triangle which has 3 sides? Who can find the triangle? And just raise your hand because I can see everybody here. And go ahead, Stella.
Maybe the one on the left bottom.
Do you guys think that's a triangle? Valerie, why is that a triangle?
Because it has 3 sides.
That's right. That is the definition of a triangle. Who can find the quadrilateral? Everybody go like this. Quad means
4.
quad means 4. Who can find the quadrilateral? Raise your hand, please. Alice.
There's a square in between 3 and 2.
Between 3 and 2?
On the bottom of the paper.
Oh, you mean right here. Now, you guys know that you could identify that quadrilateral by naming the points. Look at the points, everyone, that I just colored in. Now, I'm going to make this as big as possible. Who could name this point right here? The point that I'm actually going to color in red. Who can name that point for me? And remember, I always want you to think of your elevator first and then push the button of how high you want to go. Who could name that first red point? Who can do that? Annalise, you want to give it a shot? Annalise, which elevator is it in? Annalise, which elevator is it in?
The first elevator.
Well, so we say, you have to say the number 1. And how many floors up, Valerie, do we have to go in the first elevator?
2.
Exactly. Everybody say that out loud. 1, 2.
1, 2.
1, 2.
1, 2.
Larry, would you like to find the green dot? Actually, no, I'm going to call it the black dot. Can you tell me the coordinates of this black dot? First, name the elevator, then name the floor. What's the elevator?
1.
1. And what's the floor? How far up?
1. 3.
3. Everybody say 1, 3.
1, 3. 1, 3.
Now, I am going to give Valerie, no, I'm going to give Stella the challenge of finding that point. That point is the hardest one yet, because there's something very funny about it. And Alice, I want you to try it too, if you can.
It has no numbers.
What, guys, what elevator is that in?
0.
Oh, that's why it's so special. You literally get into the 0 elevator. And then what floor do we push?
3.
Yes, everybody say 0, 3.
0, 3.
0, 3, 0, 3. Now,
0,
raise
3.
your hand if you can name the blue point that I circled in red, if you could name the blue point that I circled in red, I'm going to go with Annalise.
2.
All right, you have to have two numbers. Like every coordinate point has two numbers. First the elevator, then the floor. Go, Annalise.
0, 2.
Oh, Annalise, you totally named it. So, Alice, next time I ask you, where is the quadrilateral? Do you know what you can say? Everybody listen to this. You ready? You could say, Mr. Kramer, it's the polygon at 0, 2, 0, 3, 1, 3, and 1, 2. That is the way to describe where it is. Now, I'm going to ask you guys one of my favorite polygons on this page is the polygon that has 14 sides. And it's actually called a quadradecagon. Can you guys say that?
Quadradecagon.
So do it again. Go with your hands. Ready? Quadradecagon. Do it again. Quadradecagon. So quadra means 4. Deca means 10. And 4 plus 10 is 14. Now, do you guys know why this is my favorite one?
No.
Doesn't it look like a doggy?
Yeah.
It definitely looks like a doggy. Now, I have a challenge question. Who could name its nose? Who could name the location of the doggy's nose? Alice, you're going to go first, but Valerie, you should be studying this. Go ahead, Val. I mean, go ahead, Alice.
13. The floor is, the elevator is 13, and the floor is 2.
Alice, that was unbelievably beautiful. Now, who's going to take the next one? The next one is going to be the end of his tail. The end of his tail. I'm going to go with Valerie. Go, Valerie.
The elevator is 17, and the floor is 3.
Oh my God, that is awesome. Now, Annalise, can you please do, oh, Annalise, I'm going to give you a hard one. You ready for a hard one? Annalise, can you give me the front toe of his front leg? What is that point right there?
0, 14.
Uh-oh. Do you know where 0, 14 is? It's right over there, because that's elevator 0, floor 14. But this one, Annalise, come on, what's the elevator?
14, 0.
Right. Do you see how importantly different that is? Now, Larry, and then Stella, you're going to do the next one. Larry, can you give me the top of his ear?
16.
Oh, that's definitely the elevator. You now have to give me the second number.
3.
Wow, that was awesome. And Stella, can you give me the one down here, which is the end of his leg, or maybe his tail? I think it's his tail.
18, 0.
Wow. You know that you guys did a better job than I ever imagined. You did a better job than I ever imagined. Now, I want you guys to go to page 3 in your packet. Go to page 3 in your packet. And I want you guys to go to look at these 7 different polygons. Now, the first challenge I have for you is to ask you a question. And Stella, I want you to unmute yourself because everybody has to be unmuted. That's important. Now, every one of the 7 is a quadrilateral, a polygon with 4 sides, except for one. Except for one. Who is going to tell me? And Annalise, I want you to pay attention over here. Try to turn your body so you are facing the screen, and that way I know you are paying attention. You shouldn't be paying attention to anything else. So now, what is the one polygon which is not a quadrilateral? Larry, do you know? And raise your hand if you know. But I want you guys to do this on your own. Remember, quadrilaterals have 4 sides. Stella, why don't you help out? Go ahead, Stella.
Probably the right triangle.
Oh my gosh. Everybody look at the isosceles right triangle. Everybody look. How many sides does that have?
3.
So it is not a quadrilateral. Now, can anyone name this isosceles right triangle by its dimensions? Now, before I have you answer that question, I'm going to name one myself, and I want you guys to then see if you could name the next one. So I'm going to name this one a 14 by 14 isosceles right triangle. This is a right angle. Everybody make a right angle with their thumb and hand, but go like this so you know that it's a right angle. I don't see, oh, Stella, you got a really nice one. Larry, you got a really nice one. Oh, Alice, yours is perfect. Valerie, yours is perfect. And Annalise is literally going like this to show how beautiful her right angle is. Now, can you pick something up that's on your desk somewhere close that has a right angle? For instance, I'm going to pick up a tissue box and I'm going to show you the right angle. I'm going to pick up directions to something I bought, and that has a right angle. Oh, Alice, that's so cool. Who else has something to show? Oh, Stella, that book is perfect. Anybody else? Oh, Valerie, that was a great example. Oh, Annalise, your green notebook. Yes. And does anybody else have any more? Oh, Larry's got it. Stella's got it. Hey, guys, check this one out. Uh-oh, wait a minute. I found another one. Are you ready? Everybody go like this with their arm. Make a right angle. You could even make an right angle on the outside of your elbow or the inside of your elbow. Now, what about another one? You ready for this one?
Yep.
How about your knee? You can make a right angle with your knee and shin, and with the inside as well is a right angle. Now, are there any other right angles? Wait a minute, I have an idea. What about your chin? If you turn sideways, does your chin make kind of a right angle?
Yeah.
Yeah, it does. Now, you guys are a little bit more beautiful than Mr. Kramer. And I think the more beautiful you are, the better is your right angle. So you guys have great right angles, and I'm really proud of that. Now, everybody look at this. I'm going to name this triangle an isosceles right triangle, which is 14 by 14. Everybody say it.
14 by 4. 14. 14.
Now, who's going to name this isosceles triangle right here? Raise your hand if you can name it.
That's all good.
And I don't see anybody raising their hand yet.
What's the question?
Because I need you to name this isosceles right triangle by its dimensions. We named this one by its dimensions, 14 by 14. So you should be able to name this isosceles right triangle by its dimensions. Who can do that? Go, Valerie.
5 by 5.
Everybody give Valerie 5 right now. Everybody give Valerie 5. It's a 5 by 5 isosceles right triangle.
I am 5.
Now, big question for you guys. Big question. Who can name, let me see if I can get rid of that. No, it's not working. I'm going to try to get rid of that circle. Who can name this? There's one square on the page. Who can name the square by its dimensions? Annalise, go for it.
6 by 6.
Everybody give her a high 6. Well, I would need one more finger. One more finger. There you go, Annalise. That's a high 6. A high 6. Who can name the rectangle? Go, Alice.
7 by 7. 7 by 4.
Wow. That is a 7 by 4 rectangle. Larry, you see that?
Mm-hmm.
Now, Larry, I'm going to give you a hard one to do. You ready for this?
Mm-hmm.
Larry, can you name the parallelogram?
Mm-hmm.
And you could name it by its base and its height. Go for it, Larry. What do you think there, Larry?
5 and 8.
Yes, everybody say it. It's an 8 by 5.
8 and 5.
But we don't say 8 and 5. We say 8 by 5 parallelogram. Now, everybody say the word parallelogram.
Parallel.
But you and say it with, put your hand under your chin and count how many times your chin hits your hand when you say it. Ready? Parallelogram. Who told me how many times? Parallelogram. Larry.
5.
Guess what? Parallelogram has 5 syllables. 5 syllables. It's a very long word. Now watch this. Everybody put their hands up like this and say parallel. Now put your hands like this and say parallel.
Parallel.
Put your hands like this and say parallel.
Parallel.
So every group of sides of a parallelogram is perfectly parallel. Now, who can name the isosceles trapezoid? Now, the isosceles trapezoid is the hardest one we've done so far. I'm going to start with Stella, and then Valerie, you're going to help her out. So go for it, Stella.
6 by 7.
6 by what?
7.
Well, keep going, because there's a base of 6, a height of 7, but there's another base. Go ahead, Valerie.
6 by 4.
It's a 6 by 4 by 7 isosceles trapezoid. Now, everybody, can you see any parallel lines in the trapezoid? Who can see parallel lines? If you can, I would love it if you told me where they were. Who can see parallel lines? Valerie, tell us what you see.
On the bottom and on the top.
Everybody go like this and say parallel. Now, Larry, you gotta pay attention, buddy. Put your hands like this and say parallel. and put your hands right on the two bases of the isosceles trapezoid, the 6 and the 4. Notice that the trapezoid only has one set of parallels, where the parallelogram has two. Parallelograms have two sets. Trapezoids only have one set. Now, who can find the rhombus? And this one's going to be harder to name. And I don't know if anybody is going to get this. So what Mr. David is going to do right now is I am going to actually copy this to another page and see if you guys could name the rhombus. It's definitely the hardest one so far. Alice, what do you think?
5 by 3 by 3 by 5.
I love what you did, but I want you to think about the length of the red line and the length of the black line. We name it by its diagonals. The red line is the first diagonal. Can you guys say diagonal?
Diagonal.
And the black line is the vertical diagonal. We go horizontal diagonal, vertical diagonal. And who can name it by the length of its diagonals? And I want to see, and Larry, are you counting? Are you going to see how big the red one is? Valerie's got her hand up. Valerie, what do you think?
6 by 10.
Oh my gosh. Everybody write that down at their rhombus. The two diagonals are 6 by 10. That was amazing. That was really, really well done. Now, I'm wondering if I create another rhombus, how many of you could name it? Are you ready? I'm going to draw a red rhombus, and I want to see if you guys can name it. And then we're going to talk about what a rhombus really is. Who thinks they could name that rhombus by the length of its diagonals? And I also want to make sure you know that this square right here is a 5 by 5 square. And that might actually help you solve the diagonal problem on the rhombus. This is hard. Stella, what do you think? Valerie, why don't you write it down? Why don't you write down what you got? And Larry, why don't you think about it, and Annalise and Alice and Stella, and see if you could figure it out. Now, just to make it a little easier, Mr. Kramer's gonna, oh, that was weird. I'm gonna draw the vertical diagonal in blue, and I'm gonna draw the horizontal diagonal in green. Does anybody want to take a crack at it? I know Valerie wrote it down already. And Annalise, you may be too close to the screen. So if you're raising your hand, I won't be able to see it. So you have to tell me if you want to give it a shot. Who thinks they can do this? All right, we're going to start with Annalise is going to give us the vertical, the blue diagonal, and Valerie, you're going to give us the horizontal green diagonal. Go, Annalise. Annalise, do you see how far this is? And remember, this is a 5 by 5 square. So we could take the square.
10.
Oh my gosh, you are right. This is 10. And Valerie, what about the horizontal?
20.
Everybody write it down. It's a 10 by 20 rhombus. And I'm going to write the word rhombus out. Can anybody help me spell the name rhombus? Help me out. Nobody would help me spell the name rhombus, so I hope I did it right. Go ahead, Stella.
RHOMBUS.
That's right. Now, who knows what is the definition of a rhombus? What's so special about it? I mean, we were looking at this rhombus here, which is different than all the rest. What is so special about a rhombus? Alice, can you tell us?
It's sideways.
Yeah, but you know, that may not be the definition of one. In fact, Alice, I want you to see what I'm going to do right now. I'm going to look at this rhombus. Is it sideways now?
Yeah.
Does it matter how I draw the rhombus? As long as, Valerie, what do you think?
Because it has no straight lines.
Oh, it has 4 straight sides, which makes it a polygon. Definitely has, but that was a great try. Larry, do you see what's special about it? Go ahead, Stella.
It kind of looks like a square.
Ooh, guess what? It has one quality that all squares have. And the one quality is all the sides are the same length. In a rhombus, all the sides, and you guys can do this, make 3 little tick marks on each side of the rhombus, and that shows that each side is the same. So why don't you guys do that? Larry, you're doing that, right? Annalise is doing it. Valerie, Stella. Now, what I'd really like you to do is tell me which sides of the rectangle are the same. And you can show me with your hands or you can tell me. We know that all sides of a square are the same. So a square is actually also a rhombus because it has all equal sides. Alice?
I was not raising my hand.
Oh, okay. I really saw your hand up, so I'm so sorry. Does anybody want to say which sides of the rectangle are the same? Is it the one that's 7 and the one that's 4? Is that the same? Well, then which 2 are the same? Guys, do you see this side and this side, the 2? Go ahead, Valerie.
The top and the bottom.
Yeah, the 2 horizontal sides are equal. The 2 horizontal sides are equal. What about the 2 vertical sides?
Equal.
Of course. So opposite sides of a rectangle are also equal. Who can tell me something else that's special about a rectangle and a square? Annalise, I want you to look up because if you're looking the backwards, you're not going to get to see it. Who can tell me something special about the square and the rectangle? Something they have in common. And Alice, if you're looking at your bracelet, you're not going to get this one. You've really got to look at the square and the rhombus, I'm going to make them a little larger. I'm sorry, the square and the rectangle. What is the same in both of them? Does anybody have an idea? Anything you see that's the same. Alice, what do you see?
The rectangle is just a little longer and the square is shorter.
Well, that's something that's actually different. That was a really good observation, but that's something that's different about the square and the rectangle. What is the same about them? And Larry, I want you to focus only on the class, not on anyone else in the room. And so you need to be really focused. Now, Larry, remember we talked about the isosceles right triangle? Didn't that have one right angle? Everybody go like this. Didn't that have one right angle? Do you see anything about the square and the rectangle that are the same? Annalise, go.
There's 4 right angles.
Yes. Everybody draw it right now. The square has 4 right angles and the rectangle has 4 right angles. And those are the only quadrilaterals that will have 4 right angles. The rhombus does not, unless it's also a square. The isosceles trapezoid is not, unless it is something else. And the parallelogram is not, because it is not a rectangle or a square. Now, my favorite shape in the whole world is what? What do you think is my favorite shape in the whole world? Who can name that? Go ahead, Alice.
Okay.
Say again.
A kite.
It's called a kite. Have you ever seen a kite fly? Have you ever flown?
I have a kite in my car. Saw a kite before.
Well, guess what? Mr. Kramer was flying a kite today and I was using it to go surfing. So my kite was the energy that allowed me to go along the water and fly in the air. So kites are my favorite shape. Who can name this kite? Now remember how we named the rhombus. We named the rhombus by its diagonals. And it was beautifully done by, I think, Valerie and Annalise. And I'm interested in who could name the kite by its diagonals. Who can do that? I've got Annalise and Valerie. Valerie, this time I want you to do the vertical diagonal, and Annalise, I want you to do the horizontal diagonal. Go, Valerie.
6.
Awesome. Annalise, you have to say 6 by what?
6 by 10.
Oh my God, guys, is the name of the kite the same as the name of this rhombus? Isn't it all, Larry, can you see that this is also a 6 by 10? Larry, can you see that?
Yeah.
Wow, that was amazing. Now, I want you guys to go back to page 2 right now. Go to page 2. And what I want you to do on page 2 is I want you guys to draw your favorite shape. You can draw a rhombus, you can draw a square, a parallelogram, an isosceles trapezoid. You can draw an isosceles right triangle. There are so many things that you can do. And if you create one then create another, and then another, and another, until you've created every type of polygon we've been talking about. Now, I'm going to actually name them by I'm going to actually highlight them for you on the page. So I'm going to take my yellow highlighter and highlight rectangle, square, right isosceles triangle, rhombus, kite, parallelogram, and isosceles trapezoid. You can make them with any dimensions you want. Now I'm going to make my own rectangle. I don't know if you guys are going to like my rectangle though. It's a little strange.
Wow.
Was that a very strange rectangle?
It's so long. It's like a chocolate bar.
Wait a minute. I'm hungry. Don't talk about chocolate until dinner time because I'm hungry. And I'm now going to make, what are you guys drawing now? I'm going to make a square. I'm going to make the littlest square I can. Look how small my square is. Now I'm going to make an isosceles right triangle, and I'm going to name it an 8x8. I'm going to name mine an 8x8. But you know what? I'm actually going to write down the dimensions. I think it's really important that everybody always write the dimensions of every figure they draw. So this is a 1x1 square. It's a 10, 20, 35. I'm going to say 34 by 2 rectangle. Now I'm going to try to draw another one. Let me try to draw a parallelogram. And anybody who wants to try to draw one too. And now I'm going to try to draw an isosceles trapezoid.
What's the diamond called?
It looks
Wait,
like the top of a hexagon.
wait, say again? Who said something about a hexagon?
Stella. It looks like the top of a hexagon.
Oh, wait a minute. Stella, watch what happens if I create another one and then I turn it around. Did I just create a hexagon?
Yes.
Oh
Yes.
my God. Stella, that was so cool. Now, what about a rhombus? Has Mr. Kramer made a rhombus yet?
No.
Yeah,
No.
I think I need to make a rhombus.
I already done.
How many of you made one?
Me.
Good. Now, I have 1, 2, 3, 4, 5, 6. What did I forget to make? Did I forget to make my favorite shape?
Yeah. Right.
All right, now you're not going to believe this one. Are you ready for something truly unbelievable? Okay. This
Yes.
is a kite, but you're not going to believe it. Can you guys believe that that is a kite?
No way. It almost looks like a paper airplane. It looks like a paper airplane.
But you know what? I'm going to name it by its diagonals. Are you ready? One of the diagonals is 5, and the other diagonal is 6. So this is a 5 by 6 kite. This is an 8 by 8 isosceles right triangle. It's a 1 by 1 square. It's a 34 by 2 rectangle. I haven't named my trapezoid yet, and I'm going to name it a 5 by 9 by 3 trapezoid. So 5 by 9 by 3. I'm going to name my rhombus a 6 by 2. And I'm going to name my parallelogram a 5 by 2 because the height is 2. Now, who wants to show me their favorite ones? Okay, Alice, you can show me, and then Valerie. Why don't you hold it up to the screen? Oh, man. Those are beautiful. Valerie, show me yours. And Larry, I want to see yours too. Oh, Valerie, keep going, keep going. Larry, let me see yours.
I can't find that's a paper, so I only have a notebook.
Oh, that notebook is fine. Can I see what you drew on your notebook? Larry, can you hold up your notebook so I can see what you drew? Oh, man, that is beautiful. What about you, Annalise? I can't see you, but I know you're there. You kind of dropped low in the screen. I'd love to see yours, and I'd love, oh, wait a minute. Everybody look at Annalise's. You know what you guys might want to do from now on? You might want to get like a red marker, because Annalise's, you can see them so well, and they're so beautiful, because I usually like pencils, but I think I really like what Annalise did. What about you, Stella? Stella, you haven't shown me yours yet. I'd love to see your
Me too.
polygons. Say again?
I didn't kind of finish mine.
You don't have to finish. I just want to see what you did so far. Oh, and by the way, if you know Mr. Kramer, you know that I have to do what with these polygons? Who knows what I have to do? Come on. Who knows what I have to do with the polygons?
Color them in.
I am compelled to color them in. And I hope you guys do the same thing. I like to color them with different. And you know what, guys? I don't like my kite because I don't think it was a proper kite. So I'm gonna make a better one a little bit later, because my kite was not a proper kite. My rhombus, I like my rhombus. I like my parallelogram.
Not like my diamond.
Oh, remember, we call it a rhombus. We do not call it a diamond. A diamond is not a mathematical shape. In fact, if you've ever seen a diamond, maybe one of your, maybe your mommy has a diamond ring that she can show you. It looks nothing like a rhombus. Diamonds are very beautiful rocks and minerals. Say again?
Your rhombus is probably too flat.
Well, rhombuses just are quadrilaterals with 4 equal sides. Oh, guys, did I forget to color in the square? I think I did. I just colored it in. Now, I want everybody right now to go to page 9. Everybody go to page 9. And you could finish your coloring work later. Now, I'm going to ask all of you to name points. Are you ready? Are you ready? And I'm going to go with you first, Valerie. Valerie, can you name the black point? Go. And Larry, you better be paying attention because I'm going to be asking you next.
Elevator is 10 and floor is 5.
Nice. Larry, you're the red dot. Come on, give me the elevator first, then the floor, Larry.
10.
No, no. What's the elevator?
15.
Okay, go ahead.
10.
15 what? How many floors up? Right. Alice, you're next. Alice, I want you to give me the green dot.
30 and 10.
We don't say 30 and, we say 30, 10. Say it again. Go ahead, Alice. Say it again.
30, 10.
Beautiful. And Annalise. Annalise, can you give me the blue dot?
35, 20.
Wow. That was awesome. And Valerie, have you done one? Or who has not done one? Oh, Stella. Stella, you get to choose whichever one you want. So Stella, can you tell me which one you want to do? You have to name the point. And then all of you are going to do your own. So go ahead, Stella. And whoever's singing, please stop that. Whoever's humming, stop humming, please. Thank you. Stella, choose a point, honey. And if somebody else wants to choose a point, you can, and Alice,
2010.
you should unmute yourself. Say it again.
2010.
I'm making that purple, Alice. That was awesome. 2010. Who would like to do a pink dot? Who would like to do a pink dot? Annalise, go. You have to name the point, and I'll make the dot. Say it again.
10.
Oh, man. You did one of my favorites, 10. Who wants to do, I'm going to pick another color. Who wants to do the orange dot? Go ahead, Val.
10:25.
Oh, man. Everybody look at that one. That one was way up there, 10:25. Now, who has not named one yet? Larry, do you want to name one?
I named one.
But why don't you do another one? You have to pick it this time. And
20.
then I'm going to do Alice. Go ahead, buddy.
2015.
2015. Oh my God. Larry, I think you picked a beautiful point at 2015. And what about you, Alice? And Alice, you get to pick your color too. I'll pick the color green. You pick the point.
5, 10.
Oh man. Who can tell me what all of these points have in common? Look at all of these points, and there's one thing that they have in common. And I chose this very specially for you. Do you guys see anything that is in common with all of those? Larry, are you raising your hand, buddy?
No.
All right. So who can tell me, and guys, read all the points out loud. Everybody read them out loud right now. Go.
25.
Keep going. Everybody read them. Go, go, go. Read them.
10. 10.
10, 10. 10, 5, 20, 10, 30, 10, 35, 20, 20, 15, 10, 25, 5, 10. What do they all have in common? They have only one thing in common. Every one of those numbers are multiples of what? Counting numbers of what?
5.
Wait a minute. 5, 10, 15, 20, 25, 30, 35. And guess what? Nobody chose a point with 0. So that point is 20, 0, and it has a 0 in it. So everybody go. 0, 5, 10, 15, 20, 25, 30, 35. Now, can you guys create your own polygons that have multiples of only, I don't know, pick a number, guys. Multiples of what? Go ahead, Val.
5.
Well, we just did multiples of 5. Can somebody pick a different multiple? Like, for instance, we know that Annalise's favorite multiples are 9. What about you, Stella? Multiples of what? Go, Stella.
3.
Oh, I love it. Why don't you guys start to do that right now? Every single one, every single point that you do has to be multiples of 3. Oh man, that's gonna be really challenging. Now, let me show you what I did for my first 3 points. I did 0, 3. I did 6, 6. I did 6, 15. And I'm gonna keep going. How about, ooh, I like that one. Let me show you the last ones I just did. I just did 321, both multiples of 3. I just did 1525. And I can't wait to see what you guys create. Raise your hand if you're gonna draw the most beautiful polygon. Who's gonna draw the most beautiful polygon? Raise your hand. Come on, raise your hand, guys. Everybody has to do it this week. I see Annalise's hand is up. Mr. David, oh, and Valerie, and Alice's, and Larry's. And what about you, Stella? Awesome. Everybody give me a right angle. And everybody say goodbye to their coolest friends, their mathematician friends, and say, Mr. Kramer, next week when I see you, you will be in Florida. We'll see you in Florida next week. Bye.
Bye.
I'll miss you guys. So
Bye.
good to see you. Bye-bye.
Bye.